We've got an informal panel. I have some questions. We'll take some questions from the audience. Uniswap v4 has been audited so far by 5 audit firms. We have representatives from 4 of the audit firms here. The final firm was ABDK. And every audit firm found at least some issues that other audit firms did not find. So every audit provided us with additional value over the others, which was really interesting to find. And yeah, it's been really awesome working with these companies. They've all been super thorough, really helpful answering our endless questions, probably going beyond what we actually paid them for, reviewing extra fixes, going over and over again, lots of things. So it's been really awesome to work with these companies. Do you each want to introduce yourselves?
Sure. I'll go first. I'm Kurt Berry. I'm an independent security researcher. I'm a lead security researcher at Spearbit, and I used to be a protocol dev at the protocol formerly known as MakerDAO.
My name is Jochen Hönicke, and I'm doing formal verification for Setora. Yeah, looking into formal how to specify the properties that we want to verify. And I come from academia. I did program verification before and wrote my own SMT solver.
My name is Jose. I'm based in Spain. I studied as a white hat engineer, and I've worked as a security researcher for Open Zeppelin for the past 2 years. I audited Uniswap X last year, and starting this year, I became a technical manager. So this year, I oversaw the audits for v4 Core and Periphery, which was quite awesome.
My name is Benjamin Samuels. I'm a senior security engineer at Trail of Bits. I specialize in node software and stateful fuzzing with tools like Echidna and Medusa.
Awesome. Quick fire first question. I'd like to know each of your favorite things about v4.
All right, I'll go first. Fine, if nobody else wants to talk. I think my favorite thing is seeing the interplay between all the different design constraints. So it's trying to be very featureful and powerful, but also secure and also gas efficient and also ship in finite time. And you see all these cool little design decisions resolving those. Like, you know, for example, the kind of hook flags being embedded in the address. You have to pre-mine your hook address for the permissions you want. And, you know, many other small examples like that.
Yeah, my favorite thing is actually the one that I showed, the new unlock mechanism, which is basically, yeah, the first time I saw it, it was quite confusing because it's the opposite way that you are used to locks. You can only use the contract if it's unlocked. If it's locked, if it's unlocked, you have to first log it before you can use it.
For me, it's the huge flexibility and customizability that the new pool manager as a singleton offers. The fact that you can do any action that you want in any number of times in any order, and also you don't even need to actually transfer tokens in and out. You can just use the awesome ERC6909 system. It's great. I've done my fair share of arbitraging in the past, and I know how important it is to shave off those extra 1,000 units of gas. So I found that brilliantly designed.
For me, it's going to be the hook system. At first, I wasn't quite exactly sure where it was going to be like helpful, but then I thought back because there's so many protocols that like have to implement some kind of AMM. Like maybe you're making a perps protocol, maybe you're doing an AMM but with a twist, and those people basically have to start from the bottom up, and that sucks. They shouldn't have to do that. But with the hook system, like you could really just build it on top of Uniswap and just have your hook and have a whole protocol in there.
Nice. I realize it'll be unfair to always go in this order, so I should mix it up sometimes. Okay. If tomorrow, well, I guess it wouldn't come out tomorrow. If at the end of the contest, it gets discovered that there's been a critical vulnerability missed by these audit firms in v4, where in the code would you most suspect it would be? We can start with Ben.
Probably in the periphery code because I didn't look at it. But actually, though, it's the sync and settle stuff. That's where the most issues have been so far. And it's really, really tricky to understand how it works thoroughly. And like when you're auditing this, at some point you're going to think that there's like a critical bug in sync and settle. You just are. And you're going to spend 4 or 5 hours triaging it and realizing that there isn't a bug there, but maybe there is. It's still probably the part that I'm least secure about.
I agree with that one. That was my first choice. The second one would be the subscriber feature, since it's a brand new one. It looks flaky, even though then it looks it is solid. We tried very hard to break it, and yeah, it's something novel. So we're still not sure how it's gonna integrate with other protocols, and also slippage checks and fee accrual. I would focus on those.
Yeah, I think I am also with the ERC20 interface and also with the hooks. It's basically everywhere where we don't know which code we are crawling. We can't imagine what will happen if someone tomorrow will write a new token that has a new mechanism that will break the invariance of Uniswap.
Yeah, I mean, this is interesting because it's specifically a critical bug, not just any bug. I mean, yeah, I can't disagree that there's a high probability of bugs, for example, in Periphery because it's newer, or in the sync settle mechanism because it is so subtle. I don't know how likely it is those bugs are going to be critical. They certainly could be. Like if there is a very deep critical, for me, it might almost be in the swap logic, some sort of very weird rounding edge case that, crosses a tick without actually doing the cross tick update, and it only happens because there's this weird rounding error that has never been hit before in the explored state space. So that's my dark horse answer.
That's fair. I remember on a call you saying you pointed at one particular line of code that was your one scariest line of code.
Yeah, it's using basically a floating point function to determine discrete value, where it's going from a price to a tick, and that just scares me just from a fundamental principle of the matter.
That's fair. Yeah, and I don't think we talked about this today, but because pools can be specified with any fee tier and any tick spacing, they're using the same maths as Uniswap v3, but in a way that it's never been used before. And so that was one of the main things we flagged to all these audit firms when we had our kickoff calls of what scares us the most. It's we're using this very well-tested v3 maths that's out there and it's been used for years, but we're using it in a new way. And is it still going to withstand all these new types of pools? So I agree that scares me a little bit. What should we talk about next? Are there particular areas of the code base that you thought were more robust, or you felt it was easier to conclude that there were no issues, or easier to conclude that it was unlikely that there were issues in there? Because I know when you're auditing, there's certain contracts where you end up spending the vast majority of the time looking at specific few contracts, and other contracts where you're this one seems like it makes sense. Jochen?
Yeah, I like this apply delta functions where you basically, if you have a normal AMM and you swap, you always have to reason when do you call, when do you send the tokens, when do you receive them, and here you just have this atomic function that is inside your contract. You have full control over it, and you only have to reason about that, and then you can separate the reasoning of the other functions.
That's interesting. I hadn't thought of it like that. Jose?
I've been thinking about this question for the past couple of days, and I don't think there's a section that you can easily conclude that it's safe. But if I have to choose one, it's what scared us the most at the beginning, is what you just mentioned. It's the fact that v3 math is super solid and battle tested, and here it was just ported, so it seemed fine, and it was kind of out of scope, but at the same time in scope, so we did not have enough time to check it. But once we ran at least some differential fuzzing on both libraries, we were quite satisfied with the result and were able to move on.
Nice.
Yeah, +1 on the v3 stuff. It's that code has already been out there, it's battle tested, and the things that we're going to change, the inputs that we're going to be now showing up in this code that it didn't experience before, were very tightly defined. So as soon as you look at the v3 code and you verify it can deal with this, this, and this, it's okay to move on. And the one thing that was kind of challenging with v3 to still think about is a lot of the Solidity code was converted to the assembly language Joule. So, I mean, if you've got differential tests for that, if you've got like a formal verification test or something, or a fuzzy test for that, then you're pretty good.
Yeah, and we also converted it from Solidity 0.7 to 0.8, which changed a lot of maths properties between the two. Maths became checked. So we had to convert anything that was using safe math previously to regular math now, and unchecked and regular math previously to unchecked maths now. So that was also a translation.
Yeah, I'd echo a lot of things that were said. You know, a lot of the code that was kind of copy pasted with just like adding an unchecked block or converting things to assembly was, you know, so long as you checked that those conversions were correct, you could be confident. A lot of the lower level libraries were very simple, and you could, you know, review them and say, okay, this is a simple object that behaves in a way I expect. But, you know, there was no like non-trivial flow through the code or like actual large contract that I thought was easy. You know, everything is pretty complicated, other than like some of the individual pieces. And so, you know, fun challenge.
I'm glad it was fun. Okay. So one thing that Sarah and I struggled with, particularly for kickoff calls, was we've obviously thought about V4 so much that it's really hard to describe V4 to other people from scratch. Like, where do you start? We tried to do it this morning as well. It's hard to explain something you already know so well in a way that other people are definitely going to understand from zero. And so we tried to give you each a walkthrough of the code base or various knowledge, or there's a white paper to read. But I'm sure there were some things that we failed in. Was there anything that you wish you had known at the beginning of the audit that you discovered as you went along that it would have been easier to just know it from the beginning? Niche question, though. Maybe you don't all have answers. For example, maybe these people want to know it now that they're kicking off auditing it. Let's start with, I can't remember who I've started with recently. Jose.
All right. All the presentations you gave us on the kickoff calls were golden. I'll give you that. That accelerated our knowledge acquiring. But there was one thing, the team lost quite a bit of time in the beginning on periphery, and it was the fact that they were thinking that money should flow through the router and then into pool manager, because they were used to money flowing out in and out of the router in V2 and V3, and that's not the case on V4. So that realization came a little bit late, and it would have been nice to know about it beforehand. But apart from that, all good.
Interesting. Because the money flows through permit 2?
Sorry?
Because the money flows through permit 2 instead, or?
Because they were thinking that the money would go to the router and then to they just had the mental framework from V2 and V3.
Yeah, that makes sense. Yeah, the money goes directly from the integrator to the pool manager.
Exactly.
And like, except in like edge cases. That makes sense. Ben?
Sure. So there's a lot of conditions under which V4 isn't supposed to actually operate. So if you have a token with more than like, I think it's 2 to the 128 total supply, like it's not expected that V4 is going to work for that. And there's a couple other assumptions like that in there as well, where you would expect a swap to work, but either because the total supply or something's wrong, it actually reverts. We had to spend a little bit of time at the beginning trying to iterate and figure out what all of those assumptions were. Another thing that we I don't think you could have ever told us this, but when you're doing an audit, like there's this balance of exploring the code and understanding it and then trying to exploit it. And I think during our engagement, we trended a little bit too much towards trying to exploit it and not enough time trying to explore it. This code is like really complicated and it looks fragile, but it isn't. It's very easy to accidentally spend way too much time trying to exploit it without having a full understanding of how it works.
Wow, interesting.
Cool. All right, do we overflow now?
Yeah.
Overflow. And you know, honestly, the materials provided were very good, and you know, like details, like write-ups, like the design decisions behind hooks. Honestly, I would echo maybe some of the like unstated assumptions like this, you know, we're assuming that tokens don't have total supply greater than an amount. And I mean, one small thing that I'd add that tripped me up a little bit is that some of the libraries in core are used as well in periphery. And initially we were only auditing core, so we were finding things like, this doesn't necessarily make sense in core, this code path can't be used, why does it even exist? And then later when we audited periphery, it's like, oh, there's that code path being used, and I had to go back and like delete my comment or whatever. I didn't delete it, I just made a note of like, okay, I see where this is used now, but keep that in mind as you're reading cores, that some of those libraries are meant to be used in other contexts. And if you find a code path that's not used, it maybe just is not used in core, but elsewhere.
Yeah, I got that comment recently about the v4 router, because you open it in periphery and it's like, where this isn't used anywhere. It's an abstract contract that's never used, and it's used in another repo. So that's a good point. Jochen?
Yeah, this was the first audit of Uniswap for us at all. So
Okay.
we didn't look at v3, and there's a lot of things that you probably take for granted. What exactly is liquidity? What is square root price?
Right.
And this was a bit of a learning curve.
Yeah, in at the deep end, going straight in with v4, for sure. But in some ways, it might have helped you. I think one thing we struggled with is because we have certain assumptions around v3, you have to try and doubt everything. Like, yes, it worked in v3, but you still have to assume it could be a bug in v4. And so maybe in some ways, it's also helpful to ignore all the prerequisites of v3. But it is a lot to learn in one go, definitely. I don't know. Oh, near misses. I liked this suggestion. Maybe you've somewhat covered some of it, but was there a bug that you were sure was in there and you spent a while digging into it and it turned out there was some check or some reason that it wasn't actually a bug, but you were convinced for a while you'd found something?
I mean, there was one thing I got a little bit excited about, which is in modify liquidity. There are no kind of like upfront checks that the ticks are aligned on boundaries. And so then I started like digging down through. I was like, why is there like, this seems like an obvious thing to check. Like you shouldn't be, writing to ticks that, aren't on the boundaries. Like, why don't you just check that as the first line? Well, I dug through. Anytime you're actually changing the liquidity, you go down like 3 or 4 libraries deep, and in some assembly code, there's, I think it's the flip tick function in bitmath is actually enforcing tick alignment if you have non-zero liquidity modification. But if you have zero liquidity modification, right, it's still a poke. You can collect fees, and it doesn't go into those flip tick functions. And the way it gets prevented there is because there's a check in, I forget which function it is, but it says you can't poke positions that have zero liquidity, and because of the checks in flip tick, only aligned ticks can have non-zero liquidity, and so it was actually like quite subtle how it was never possible to do bad things to misaligned ticks, but ultimately it was not a problem.
Wow, I don't think I could have told you all of that off the top of my head.
I reviewed it before,
yeah. Amazing. Jochen?
Yeah, there was this, there's this ESE 6909 token where you have a UN256 for your token number, and this is a bit longer than the address. And there is this subtle bug that you can just mint this token or settle to this token and keep the high bits different than 0. And this basically brings you, gives you multiple accounts for the same token in the contract. But it still works out because if you sync one token, then the balance is already updated and you can't sync the other equivalent token again.
Nice. I remember, I think it was you guys that brought that one up with us, and we have now made it so you can't do that. Even though that wasn't necessarily a bug, it was weird. Nice. Jose?
We also went down that rabbit hole. We still a lot of time over there. But we also spent, and we're kind of sure that we were going to break it, the subscribe, unsubscribe, try-catch block. We were looking for any chain that you could still self-destruct so that you could crash that try-catch block, but eventually we did not find anything since it's been deprecated everywhere, and we had to move on.
So when you're initializing liquidity, when you're initializing a pool, you don't have to add any liquidity to the pool. And you can set to whatever price you want. And that really tripped us up because you could set it to any price up to the maximum square root price and between the minimum square root price. And depending on your tick spacing, that price that you set might actually be above the upper bound of the allowable tick. And we thought there might be something with that, and it was a huge rabbit hole, and we spent way too much time on it. But it's like the first swap through the pool is going to fix it, so it doesn't really matter. Yeah, there's a lot of rabbit holes where like you're going to look at a function and you're going to be like, oh, wow, this is totally something I could break. And like was said earlier, the thing that actually verifies that that isn't going to break is really far away in the code. It's deep down in a library. It's deep down in like bit flip math or something. It can be try to optimize how fast you're going to be verifying these things, because if you spend too much time on it, you're going to spend your whole engagement just trying to verify issues.
And to defend the code slightly, I mentioned the constraints earlier, right? Like having those checks buried where they only get invoked in very particular instances is saving gas on every other call where you actually wouldn't really need to check it because it can never happen in the first place. So it's in line with the sort of balance of constraints, but so I don't want people to think the code is just bad because of that. They did it for a reason.
Yeah, it's done for a reason. It is a little bit scary though, I see that, because if we then change something at a library level, it's hard to see like all the ramifications it can have all the way up the stack. But that's why you have lots of tests.
Be warned, forkers.
Pardon?
Anyone who forks, you know how like people fork protocols and then they screw it up and they get hacked? If you're thinking of forking V4, just know you're probably going to get hacked. Like I'm just, it's true.
Build a hook instead. Yeah, I think even if I forked V4, I'd probably mess it up. Nice. Okay. Was there any techniques you used for V4 to help you verify whether a bug was correct or not? Or something around that? Ben?
So for most of the engagement, I was working on our stateful fuzzing harness, which involves working with their test suite, working with the fuzzers. It's very easy to build a POC when you're down in the trenches trying to like fuzz the code. We got a lot of value in using the actions router class that's in the test suite. You really want to optimize on being able to write up a POC really quickly, test it, verify it, make sure it works. Yeah, that's probably the best advice I've got.
Nice. Shout out Sarah for writing the actions router. It's a, for context for people who might want to use it for proof of concepts, it's a test. It's a contract we have that we only use in tests. Much like those command-based contracts we ran through earlier, it's a command-based contract that also allows you to do, you can basically write a test with any succession of actions and checks. So you can sync, and then you can get it to look up a certain value in the contract and check that it's correct. And then, and you can add new, I'm sure you guys probably added new commands to do extra checks. And so we use it often to like pull together a quick test of, oh, what happens if you do sync and then settle and then another settle of this thing and check that values are correct in between. It's like you can chain together these actions in any order. We also love it. Right. Cut?
Yeah, I mean, I've got to echo, you run the tests, be able to modify them, leverage the infrastructure that's there, because it'd take you a long time to write it yourself. As far as verifying bugs go, I mean, whenever I'm trying to verify a bug, I'm always trying to like find the reason it doesn't work as quickly as possible so I can move on to the next thing. So that's maybe just a more general strategy of, okay, how can I prove that this is safe? Like, what's the quickest way that I could convince myself it's not safe? If you keep convincing yourself that it's wrong, it's more likely that it's a problem. And I think that is especially relevant on very mature code base like V4, where it's actually more likely you haven't found something. So you want to try to prove that it's think I'm going at it like I'm going to prove it's safe rather than, okay, it's definitely a bug, I'm writing an exploit. And sometimes that'll get you an answer quicker. Interesting.
I like that. Jochen?
Yeah, I'm in the formal verification guy, so I don't write the exploits. I just say this could be interesting. Anyone else wants to try it out?
Nice.
But yeah, we actually don't have the problem with trying to prove it's safe, because if it's safe, we we don't even see this bug. We
Right.
get a counterexample, and then we need to figure out if this is prevented somehow.
Okay. So yours is like you get a rule that breaks and you have to figure out if it's a problem with the code or a problem with the rule.
Yeah, so if this edge case is really allowed or not.
Because you can also have over approximations, right? Which is where the prover can say it's a bug, but it turns out to be fine, right?
Yeah, of course, the provers also sometimes over approximates.
I remember early on you coming to us with something where it was a rule that had broken, and it was because you were running you were converting our fuzz tests into formal verification rules, and there was one that was breaking, and it was because you were using our test router, which for no reason at the end of every transaction sweeps extra ETH back to the user at the end of the test. And because the formal verifier was just like seeding the contract with ETH, the user was ending up with way more ETH than they were meant to or something. And so it was actually down to our test contract having not quite a bug, but just like a strange behavior that was breaking a rule. Jose?
Well, not much to add to what everyone said. We did a lot of fuzzing, and the test setup that you had was quite helpful to do that quite fast. And apart from that, what I said in the beginning, differential fuzzing to V3 libraries and V4 libraries to make sure that the outputs were consistent.
Nice. I feel like we've covered a lot of this. Even the ones I haven't asked, we've like, any particular things you want to talk about? Or I can turn it out here. Oh, wait, no, we haven't talked about this one. Can you talk about one of your favorite bugs that you found? A real bug. There were lots of them. Who wants to start? Jochen. Am I saying your name right?
Yeah. Yeah.
Yes. Okay.
Yeah, so I think one is the one that we discussed that wasn't really a bug. This
That was
M2,
a good one.
which basically is, the price doesn't need to correspond to the current tick exactly, so it can be even the next tick. And other things were these inline assembly code where it's a potential bug if the next compiler version changes the behavior, like initialized high bits or using memory locations that are reserved by the compiler.
Nice. Yeah, I think Satora M02 is probably the issue that caused us the most stress internally. It took us maybe 6 weeks to conclude that we weren't going to make any changes. And we wrote a fix. I wrote a fix. A girl on the team wrote a fix. Someone on your team wrote a fix. And for all of them, the formal verifier said we were still wrong. So eventually, we've ended up concluding that we're not going to redo the whole swap function to fix this issue. But it's an interesting one to dig into. Satora M02. It's going to be with me forever, that one. Jose?
Well, for me, the favorite one and the one that I want to discuss because of the underlying reasons was the critical found on core, although Sarah front-ran me earlier with the description of the issue. But this double entry bug was I wanted to talk about the thought process we had in order to figure that out. The first one being the multi-chain nature of Uniswap. It's deployed basically everywhere. And it used to be enough as a security researcher with just checking whether push 0 was available on the other chain or not. But nowadays you need to be up to date with multiple nuances on the and behaviors on different chains. And sometimes it's actually hard to keep up. Some precompiles may work differently on CK-Sync era. Some tokens may have this double entry point, and you need to be aware of that. So that was one source of thinking. And the second one was sometimes when you have a very flexible and complex project such as Uniswap v4, there are numerous ways to do things. And whenever there are 2 or more paths to do the same thing, we dedicate quite a lot of time to make sure that they actually do the very same thing. So we found that you could actually settle the native currency, or you could actually settle through the ERC20 contract address. So that's 2 ways of doing different things, and the logic was quite different. And combining those two thoughts, that's how the critical span out. And it's, well, it's something we should all have in our tool chain every time we audit a multi-chain project.
Yeah, definitely. I feel like it's so valuable to have a list of weirdly behaving tokens that are still like valid tokens. There's lots of weirdly behaving tokens that we would just ignore. Like there's an owner who can just take everybody's tokens from them. Like we can't protect that, but something like a double entry point and stuff like that is rebasing. There's so many strange tokens out there, and some of them work on V4 and some of them don't.
To add a little bit more insight on the double entry thing, we identified 3 tokens. One was the Celo token, the other one was Matic on Polygon, and the third one was actually ETH on CK Syncera. And we could manipulate deltas on the three of them, but we could not call take and actually withdraw and drain the pool in CK Sync because it doesn't have a transfer function. It's really not an ERC20 compliant token, just a contract. And on Matic, there's a check enforced where it checks that the amount you're transferring matches message value. And in that POC, it didn't work out, only on Celo. So interesting insights.
Yeah, super interesting. Nice. I can't even remember who we've spoken to. Ben.
So my favorite bug is the one with syncing and collecting protocol fees. It's a low bug, and like realistically, it's not something that would actually get exploited in the real world. But it's a flaw involving 2 parts of the code base that are really far away from each other conceptually, and there's still this like assumption that was being made there that ended up being incorrect. Originally when we went into the audit, I'm guilty of this. I know a lot of other people are guilty of this, but you go for the headshots. You're trying to find the most critical issue, and if you try to go into this with that approach, it's not going to be very good. It's not going to work very well for you. I don't know. Maybe you'll find something like the double reentrancy thing, but this one finding that we had, it was so subtle, and like these parts of the code base that were completely apart from each other is really cool. And I expect that if there's going to be other findings in this contest that aren't critical, it's going to be similar, where it's these 2 parts of the system that are really conceptually very, very far away from each other, but they're linked by like this one little bit, and there ends up being an assumption there that is broken.
Yeah, that one was a very cool finding. I think your Trail of Bits' core audit report was the last one we got back. So you were given some fairly well audited code already, and that was just like, a really cool find of a way of manipulating balances between sync and settle. It was very interesting, that one. Cut.
All right. I also got front run a bit by Sarah. I was going to talk about the, skipping of the unsubscribe call by manipulating the gas amount provided. So
I feel like she didn't really talk about the 63/64 thing.
I can go into, I'll go into a little bit more detail about it. Right. So I think it's interesting because it's this example of trying to balance trade-offs, and the thing that's maybe maximally good for the user, where you just completely ignore any failure from the subscriber, is sort of maximally bad for the subscriber itself, because the user can just supply enough gas where the subscriber call will run out of gas, but the overall function finishes, just completely skipping that call. And so the fix was to put in this check to make sure there's enough gas left. Then there's this subtlety because the EVM has this 63/64 rule to prevent like infinite recursion or infinite call stack depth. But even after you put that check in, it's still a little bit suboptimal, because now the subscriber has the right to waste a certain amount of the user's gas, even if they don't need all of it, because you're saying, okay, the user has to send at least this much gas to be able to give the subscriber. But if the subscriber only needs 1/10 of that, they can try to waste all of it to grief the user. So now you have this parameter that kind of needs to be set pretty carefully and tuned, and it might even need to be dynamic, because like your underlying execution environment can change on you, right? Fortunately, there haven't been a lot of hard forks lately that changed gas costs, but like back when I was developing at Maker, that was something like every few months, like, oh hey, the storage opcodes are changing in price again, and we have to rethink everything, or recheck our gas optimizations.
Yeah, I think both core and periphery have a gas limit for a specific call. In core, it's the setting of protocol fees. You'll see a very similar setup. They're actually different now. The design was we want them to both work exactly the same. It's this idea that you have a call and you want to fetch some sort of external information or carry something out externally. But if that call fails or that actor is malicious, the call still has to succeed. So it's this model. And we limit the gas to the call. And then even if the call fails, we continue onwards so that that call can't revert the execution. And it's really hard. We've spent a lot of time talking about these, and I think it's one part of the code that I think it's a part of the code where we will never feel 100% content with the design because of what you're saying of you have to protect the subscriber to a certain extent, and so you have to pass in, you have to do certain checks, and you have to pass in a certain amount of gas, but then the user then has to, if you say, okay, any subscriber can use up to 100,000 gas on unsubscribe, then to protect the subscriber, the user has to send in more than that amount. But it means if a subscriber only actually needs 10,000 gas, the user has to send in 100,000 anyway, and the subscriber could then burn all of it instead of the user just sending in as much as they're happy to spend on that. And I don't think there is a solution that we're 100% happy with. We've come to a middle ground, but
I mean, you could let subscribers somehow provide the amount of gas they're willing to use, and then users could, decide in the subscriber market which limits do I trust
look
more.
at Sarah's face.
Yeah, they're really not any I haven't found anything where I'm just like, oh, that's perfect. Everybody is protected, and there are no bad edge cases.
Right, and the future-proofing thing. So we had a model for a while, and we actually have this in core, I think, in our final design, where. And this actually came from someone at Opens Upland, Nikita, who was on our core audit, came up with this idea of saying, instead of passing in a hard-coded gas limit, to make it future-proof, you could just pass in you can give the external call a percentage of the block gas limit. And that means that external call can never use the entire block gas limit and prevent someone from carrying out this action. And they just have a hard-coded percentage. And that gives you more future-proofing, because if the gas costs start changing in future, let's say gas starts going up, but block gas also starts going up, that percentage increases over time too. But I think we've ended up with that in core, but not in periphery for various reasons. We've spent a long time talking about gas on external calls. One of our favorite topics. Have we spoken to everyone? I think so. Yeah. Are there any questions from the audience? I feel like, yeah.
In the process, we have an engagement with the consensus mechanism, with the topology of the network, with the meme pools. Any check failures on that level?
Generally not. For the most part, when you're auditing smart contracts, so long as the chain will come to consensus, that's mostly what you care about. The one thing that you sometimes consider is eclipse attacks, right? So, and the general defense for that is that a transaction needs to kind of fully encompass the user's economic intent, so that it can't be used or say replayed in a different context, right? Because a classic eclipse attack, for anyone who's not familiar, right, is the topology of the network means that you're connected to certain other nodes, and if you're surrounded by a malicious set of nodes, or you have malicious peers, they can kind of fool you into thinking that certain things have happened in one way, but they have actually happened in a different way, and you think something has happened, like you've sent a transaction in the context your malicious peers showed you, and then they take that, they replay it in the real world, and it does something you didn't want it to do, right? Like you said, I want to buy, I want to make a swap, up to some slippage limit, and then it turns out that that slippage limit in a different context is, very bad for you. Like maybe you said, I'm willing to swap up to a particular price, and you thought that price was close to the price of the pool, but in reality, it's very far. I don't recall seeing any issues with that while I was auditing the V4 code, but I've definitely encountered that sort of thing in the past. And other.
I've got a thought. So all the stuff that you said, yes. One finding that we had that was kind of like, it's not really a flaw in the smart contracts at all, is that these hooks that you can attach to pools, you have to grind out the address to get the configuration right for those first couple of bits. And one thing we were thinking about is theoretically someone could grind out a hook address that looks just like another hook address. And so maybe there is a USDC ETH pool with a specific hook address, and everyone uses that pool for doing everything. Someone else grinds out a similar address, creates another pool, and tries to fraudulently get people to swap through that pool, maybe through like some kind of front-end attack or something. The question was, how would a wallet be able to inform someone that they're swapping through a malicious pool? And it's kind of still an open question. I think it's up to the wallet people to figure that out. So good luck to them. But yeah, sometimes you do look to those outer edges, but like once you get to like the consensus level stuff, you only care about MEV. Like you only care about what happens when something can be sandwiched, what if it can't be sandwiched or like backrun or whatever. For V4 core, like none of those assumptions are built in. Like you assume the periphery contract is going to take care of like, the limit stuff, like you said. And in terms of not getting sandwiched, other than the limit stuff, like it's just something that you can't really address at the smart contract level.
Mm-hmm. There was an issue on OpenZeppelin's core report where our response was, we'll fix this in periphery, where it's like, yes, that is theoretically true, and integrators should be careful to fix that, but it's up to the integrating contract. I can't even remember what the issue was. I just remember us saying, we'll fix it in periphery.
I think it may have been the front-running pool initialization issue.
Oh, yeah. It's one of your mediums. Sarah and I reel off, like, you know how people talk about EIPs, where we talk about 1155, like it's like a really common thing. Sarah and I are like that with audit issues now. We're like, oh yeah, OpenZeppelin H01, blah, 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 blah. We do that with all the audit reports. I know all the numbers.
On the subject of, if we want to include sandwiching here, which, semantics of whether that's a consensus layer thing or not, the donate function in core is actually very easily to sandwich with, just-in-time liquidity. We kind of decided that was more of a problem for users of the donate function to solve rather than something that should be enforced in core, because there are many ways to solve it, like lockups on user positions, or gradually distributing rewards rather than doing it all in one big donation. But that is a tricky design consideration for hooks or anyone who wants to use the donate function. Very, very easy to sandwich, and you'll have to figure out your own solution for that. Now, you look at, like, say, ERC 4626 vault designs, they all have some sort of solution for this, variations on it. But yeah, that is a bit of a gotcha if you're going to use that function.
I believe you reported it as an issue, and we just added a comment.
Yeah, the fix was the fix was adding documentation, which honestly, like, I would have made the same decision as a developer, because it would add a lot of complexity to core, and you don't want to mandate the solution. But,
right. No, it's definitely something to be aware of. Nice. Any other questions? Yeah. Yes, many. If you look in the code base, by far the longest fuzz test we have is of that behavior. It's by far the longest fuzz test I've ever written, because there's so many different cases. So one that I briefly mentioned earlier is when the pool is running out of liquidity. If the pool is running out of liquidity and the hook doesn't have sufficient checks, the user can drain the hook. We've ended up concluding that one's okay. It's more that hook should obviously have checks in place, and this is a hook that's giving away money to the user. So let's say there's a hook that gives 100 USDC on every trade. If the pool only has 1 USDC of liquidity left to trade, and so the user says, I'm going to trade $1,000. The hook says, we'll give you another $100. So there's $1,100 going to be traded. Only $1 gets traded. And then whatever's left over gets credited to the user. So then $1,099 get credited to the user, even though the user only ever put in 1,000 at the beginning. If you're interested in more, I'd recommend looking at that fuzz test, because for a fuzz test, you have to specify all of these edge cases and basically acknowledge it and say what should happen and whose delta should be what at the end. And that had to be one of the cases of, like, if this very strange hook exists and they don't check that there's any liquidity in the pool, expect that the user gets all the hook's money. And we had to write that into the test. Did you guys have anything else around that? That was...
I mean, I would highlight from your answer that most of the risk is to the hooks, yes, rather than to users or to the or to other pools, because of the way the delta accounting works. You know, the hook is just on the hook, so to speak, for whatever modifications it wants to make, you know, to the delta or whatever it wants to specify. And so, yeah, hook development and I guess hook audits are going to be quite tricky in the future.
Yeah, very tricky, I think. Yeah. Anyone else have anything around custom accounting? No. Nice. Any more questions? Yeah.
Just one question about rebasing tokens and build approving tokens. Is it like the same limitation as in free, so you cannot really supply without also providers?
Yes, rebasing tokens are not supported directly in Uniswap v4. If a rebasing token rebases up, that interest is lost. And if it rebases down, then not everyone's going to be able to withdraw their liquidity because tokens have disappeared. Instead, we recommend wrapping the rebasing tokens. So for example, in V3, people trade wrapped stETH. What's nice about V4 is we have a proof of concept hook somewhere that does this. You can create a pool for the rebasing token that's essentially a ghost pool that doesn't have any liquidity in it, and you get the modify liquidity function to always revert. And then you can, in the hook, so if someone goes to swap, you can use custom accounting. Someone says, I want to buy one stETH, which is a rebasing token. The hook takes that stETH, wraps it, trades it behind the scenes on the wrapped stETH pool, and then funnels the output of the swap back to the user, and it looks to the user like they swapped on the rebasing token pool that actually doesn't exist. And it's behind the scenes trading it on a wrapped rebasing token. That might be, we have a proof of concept somewhere I can send you. Any other questions? Yeah?
It's more like a request. Because I feel like you thought of everything: formal verification, the differential testing, logical flaws with the check-ins, the CO somewhere else, limits in the inputs, maximum values and everything, different curves that you can apply. Like, it feels like everyone has thought about everything. So, and losing time in rabbit holes is super important. So it would be so cool to have like a checklist of everything you have done. You know, if it's possible to create that, because that resource would be very useful to save a lot of time when you bring up to an application.
Mm-hmm.
So in the Trailbits audit report, there's a coverage section, and it says exactly what we looked at and how we looked for it. Yeah, so that we're covered. Yeah, yeah. All of you should look at all the audit reports and read them before you even look at the code. I forgot to mention this, but that's so important, because you want to know what has already been reported, and you can get a good idea of what people have been looking at through like coverage sections or like when they describe the system. You want to get an idea of what they've already looked at, because you don't want to duplicate their effort. You don't want to go and like formally verify that the V3 Solidity library equals the V4 Yule library, because someone already did that. So it's really just trying to figure out what did other people look at and focusing on what they didn't look at.
Yeah, for example, what you said about the checks in the Fitbit. 3 days ago, I was reading the code, I'm like, oh, the check is missing, where is it? And now you said it's like, okay, I'm not going to thinking about it. So I'm like, thanks for saving me a few hours.
Nice.
No problem. I mean, make sure I'm right about that. Maybe there's an edge case. I don't know. But
Yeah, that's true.
I'd also say, first of all, Core has had more audits than Periphery. Core has had 5 audits, including formal verification. Periphery has 3 audits and no formal verification so far. And just because core has been audited 5 times doesn't mean that all of the code has been audited 5 times. There are changes that have been made in the last week because of audit issues that came back. That means there's areas of the code that function differently now to how they did in any of the 5 audits. And so if you look at a diff of the code now to the code 2 months ago, 3 months ago, the areas that have changed the most, I would say, probably have the highest risk of flaw. So in core, Sarah talked about it earlier, but the number of times we have changed the sync and settle mechanism, because I think every audit firm basically came to us with some problem in that mechanism somewhere. Diffs in that, and periphery, I would say, is more likely to have a bad bug than core, is my prediction, but maybe I'll be proven wrong.
Yeah, if I could add one more little bit to that. Earlier, you had asked us, what are we most like secure with in the code base? And we all mostly said like the V3 stuff. I mean, there you go. We mostly didn't look at the V3 stuff.
Oh, maybe there's bugs in that. Kidding.
I hope not.
I would also add that I agree, you should read all the reports and you'll get a sense on some patterns on where these bugs stem out. We mentioned a few sections, so I would also check the fixes for those issues. There were a lot of issues, a lot of rushing, and we had way more time to look at the code base than to look at the fixes. So of course we reviewed all the fixes properly, but I would focus on those. And also V4's been out for over a year, but what everyone audited is quite different than what came out a year ago. So there were changes in the last 3 months. So obviously something that has 3 months of life is more prone to errors than something that's 1 year old. So I would focus on what those differences are and take a deeper look.
Definitely. And we even mentioned this internally, and then it ended up coming to get us. So if you get two audit reports back and you're fixing bugs from both of them, and then you're sending the fixes back to those audit firms aren't always aware of the bugs that the other audit firm found, and how your fix from one might be affecting fixes from the other. And from our first set of audits, I'm going to remember this incorrectly probably, but there was 2 fixes we applied from 2 different audit firms, and we essentially introduce a new bug through those 2 together, and each of them independently reviewed the fix that they were given. And I think on day 1 of Spearbit's audit, someone was like, oh, because we gave you a commit like 2 days late. And so someone looked at the diff between what were we given on Monday and what's the commit now on Wednesday, the final commit, and someone was like, these 2 pull requests that have been merged have introduced the bug together. So whilst we've had all these audits and had all these fix reviews, like we've merged a bunch of audit fix improvements in the last week, and yeah, it makes me nervous that we could have done that again. Thankfully, the one we introduced wasn't bad. It came out as like an informational or a low or something, but it was like, it's proof that we're all human, and there's like a limit to what audits are capable of. They're an amazing tool for finding bugs, but they're not bulletproof, which is why we've had so many and why we're now having a competition. Yeah.
So if I could maybe synthesize the responses to the original question, which was, it'd be great to have a list of everything that's been looked at. I think rather than thinking about avoiding things that have been looked at, you should instead just be thinking, what are the highest probability places for there to be issues, which is going to be evidenced by what's had recent changes, what are the new mechanisms, what has less testing, because I think at this point, a lot of things have been thought of. And so rather than being like, what should I avoid? It should be more, where should I be looking, because you can get a lot more clues about that.
When we do our report, we also have not only the bugs we found, but also the properties that we actually proved. And you get the list of properties. And if there is a bug fix, we can just rerun our tool. And sometimes you have to change it. If the settle mechanism changes, then you can't use your old properties again. But if you're lucky, you can just rerun it, and it tells you there's a new bug here.
This actually happened. We fixed There were two issues in the Satora report that were closely connected to each other, and we fixed one, and we hadn't fixed the other, and they ran their properties again, and we broke another formal verification rule because the fix to it was going to be to fix the other issue. I think the rules have now been run again on like a more recent commit, so things are looking good, but yeah. Hopefully that gives you some tips at least. Any more questions? Yeah?
Do you have any list of the properties when in your report you have some portion of the properties you actually approved?
Yeah, so in the report, we first give the bugs we found, and then we give all the properties we looked into and approve a result for them.
All the reports are on the repositories on GitHub.
And we usually also link to a website where you can look up the exact property, the source code basically for the tool.
Quick disclaimer on the reports, a couple of them, spear bits in particular, are still in draft phase. So, you know, the issue write-ups are probably all finalized, but in some cases we haven't fully reviewed the fixes yet, or the fix reviews might still be in progress. So that's maybe another place to like look for, you know, where should I start, is like, you know, things that aren't already marked like verified. You know, maybe we haven't gotten to it yet. Maybe we missed something in the fix.
Yeah, I think 3 of the 5 audit firms that there still are in draft, and ABDK's report doesn't say we fixed any of the issues because they just haven't got around to reviewing our fixes yet. So it currently says that none of them have been fixed, and some of them obviously have. Sarah?
Was there any feature or maybe optimization or code change that you were like, dang, this is missing from the code? Or like you wish you would have seen?
So like things that, like if I were to write the code, what would I do differently? Oh.
Yeah, or maybe like if you have audited other AMNs or anything, like you like some kind of feature that before didn't have.
I mean, I feel this is a bit of a trap question because, you know, like I said earlier, I gave this example of the tick checking, right? Where like there was many things where I'm like, I would have rather just like put very clear upfront checks, so that you knew what assumptions you were working with, and like certain things weren't possible. But, you know, like I said, I think, you know, the code probably got to the state it did because of this like, you know, manic drive to optimize it and, you know, not have external libraries, introducing external calls. And so like under the same, like I didn't live for, you know, a year of development under the same incentive set, right? And as a security auditor, I'm like, well, this is how I would write it to prioritize security over everything else, right? But then you start saying, well, there's gas, there's feature richness. You know, I still think maybe there could be a little bit more like explicit checks, or at least explicit like commenting of some of the subtle stuff. This is a common thing I see in many code bases of like, we will religiously like do nat spec for every function parameter you could have guessed the meaning of just by reading the name of it. But like this complicated multi-file interaction, you know, you just kind of have to figure it out.
Yeah.
So like if you look, for example, at like very low level code for like drivers or something, you know, or just really like detailed stuff, a lot of times the comments are longer than the actual code. And that's something I'd like to see more of in general in these like very complex, very high stakes DeFi systems of like, yeah, like the actual justification for this one line is like 3 paragraphs and it's right here. And you know, like what all the other functions that interact with it are. So maybe that's what I'd say, is assuming that, you know, the incentives have been balanced correctly, maybe just more explication in the code of this is why it works this way, even though it's like pretty weird.
Yeah, I know in particular, Solomon and Natalie from one of our Spearbit auditors made multiple requests like that. There was a long issue about proving that all of our unchecked blocks were safe, because we just didn't even have or some of them we'd have like a 1-line comment, or some of them there'd be no comment of saying why it was safe for the math to be unchecked. And so that was an issue brought up of just like, can you please, like we've checked that they are safe, but can you please comment why they're safe?
Yeah, that's an excellent example of this.
Yeah, if I could add something that you might change, you should have written the whole thing in Huff.
Oh God.
But like more realistically, as protocols try to do like more and more stuff, and they try to be more and more optimized, there's this tendency to have to work around the Solidity compiler. And as a result of that, there's added complexity. You have to like drop into Yule and do stuff in there. Now you got to worry about, working in Yule. And it feels like we're starting to get to a point where everyone is trying to work around the compiler a little bit, especially with the slot zero stuff. I saw that and I was like, oh yeah, the structure packing is a little bit of a problem. But I don't even think this is something that you guys could do. It's something I think the community has to address and start thinking about how we actually have to design these systems, because it is getting very, very complicated. And if the compiler was perfect, and no compiler is ever going to be perfect, I feel like a lot of the complexity could have been abstracted away or just ignored, and you'd have a more secure protocol because of it.
100%.
Building on top of what Kurt said about these non-explicit checks that end up being fully secure, I feel like that's some signature touch from Uniswap code. I've seen it in almost every project I've looked at. I remember from Uniswap X, there was one check where I lost a bunch of time. It was clearly wrong. It had to be wrong. It turns out it wasn't. It was very well thought out, and whoever coded it thought about every potential scenario and knew that could not happen. So that's a double-edged sword, because first, either you go down a rabbit hole or you think, oh, these guys know what they're doing, so I'm not going to check it, and then you miss something. So yeah, I kind of like it, but it's also difficult to audit, yeah.
Yeah, and I think it means, like, obviously we've ported over a lot of logic from Uniswap v3 to Uniswap v4. Well, Sarah and I didn't write Uniswap v3, and so it gives us the same scaries of, we're using this library that we didn't write, and so you then have to spend a lot of time digging into everything that library does and how it works to then feel happy using it again elsewhere in a different way.
I think this compromise between security and gas optimization, this is always a problem. The many places where you use inline assembly, and then you need to think about the dangers of inline assembly, that some parts of the words are uninitialized according to spec, but it may not occur with the current compiler version, but later maybe.
Yeah.
And on the other hand, this settle mechanism that was this new settle mechanism that was introduced for security also basically made some old use cases not feasible anymore. So you can't send multiple tokens at the same time.
Yeah. Once we've got more L2 use, we'll get rid of assembly use.
Is there a feature that you couldn't find verifiably find an attack vector for, but to this day is it still bothering you, that you're still uncomfortable with, that if you were Uniswap's CTO, you would have vetoed that feature? You would have vetoed it?
Wow, vetoing a feature.
I mean, your inner feeling about features, not.
That's a good question. I mean, because on the flip side, I see the power of a lot of the features, like, for example, the hooks are terrifying, but that's kind of the whole point, right? Like, why are you even doing V4 if you're not going to have hooks? So like, I don't think I would have vetoed hooks for sure. I don't know, maybe the subscriber feature, because that is something that could in principle be built on top. Like the advantages that it gets of having this like more trustless staking experience, you still have to have some degree of trust to the subscriber, because it can like veto, it can revert everything but unsubscribing, and that can be quite annoying and inconvenient. And like just a third-party staking contract can still be like formally verified and audited, and our staking contracts are, for better or for worse, one of the most common types of code you see, and they're getting better all the time, and there are standards for them now and things like that. So maybe I would have looked at that and said, okay, nice in principle, but I don't think we strictly need it, and maybe we should put more energy, into making sure other things are safe and secure and robust. But I don't know. I don't look at any big piece of the code and be like, yeah, just throw it out.
Are you actually asking like, where do we think, like, where's the riskiest trade-off? Because that's kind of what it sounds like the question actually is.
Yes, what bothers you the most? I mean, if you could find a verifiable attack vector, I would have seen it in the report. But
Yeah.
is there something that you couldn't find an exploit for,
Okay.
but it still bothers you internally?
I've got something that bothers me.
Oh, no.
But see, the thing is, this bothers Uniswap as well. So like, I don't know if I can really say it is that, but so transient storage is per transaction. It's not per call frame. So you could have someone lock the Uniswap core, do something, unlock it, do something, relock it, and then unlock it again, do more stuff and relock it. All that transient storage is going to be shared across all of that because it's all the same transaction. And I hate that.
Right, because if there's anything left that's non-zero from the end of the first transaction, you
Yeah.
can't assume it's going to be zero at the beginning of the second one.
Drives me nuts.
Wow, I haven't heard that answer before. I like it. Except I don't like it.
This is interesting because at one point we were over the bytecode limit and we were talking about what we wanted to remove. And I think the first on the docket was 6909 functionality.
We actually wrote it at one point as not 6909 compatible, like way more minimal, no approvals, like it was just a mapping of like, this is what you own in core, because we were battling the 24,000 kilobyte, whatever it is, contract limit. Every time we compile the code, one of our gas snapshots, which we talked about earlier, tells us how big the contract is. And we're really at the borderline. I think it was one of the Spearbit issues. We wrote a fix. They checked that it was right. They put in their report that we'd fixed it. And I had to message them the day before the contest and say, I just thought you should know we didn't merge this pull request because it pushed us over the bytecode limit. So please, can you mark that we have not fixed the issue? And it's like an informational issue, I think. It doesn't matter. It would have been nice to fix it. But yeah, we're on that limit. But I think 6909s were like one of the, if you had to remove something to save bytecode, we'd have removed that.
But also, it's not like a particularly scary feature either.
Any more questions? No? Nice. Well, let's give a big thank you to these auditors. I think we've felt very lucky at Uniswap Labs and Foundation to have an amazing opportunity to work with so many top audit firms. And we've learned so much from all of the auditors and all the companies we've worked from. And yeah, and it's amazing. I think all 4 of you have flown in for today. Have you? Did you as well? Yeah? Yep. Just to be here for this panel. So yes, thank you so much for coming.
Thank you.
Thanks for having us.
I can handle it. Don't worry about them. Okay. Thank you, though.